Hi there, some of you may recall that a while back I put the Howell V-twin engine build on hold because I was struggling getting hold of some gear cutters. And then I got sidetracked and I started making a hobbing machine. But now I've got all the 4 gear cutters that I needed together with the hobbing machine. So in this video what I'm going to do is make all the gears for the Howell V-twin using a combination of my gear cutters and the hobbing machine. Now for anybody having a go at making gears for the first time, I would highly recommend this book. And I bought this a couple of years ago. When I first bought it, I opened it up, had a quick read, didn't understand any of it, put it back on the shelf for a year. And it lived on the shelf until I needed to actually start cutting some gears. And I think it was for the Jerry Howell hit and miss engine that I made. So I got it off the shelf again and had another read, and things started to gradually become clearer. And there's some really useful information in here, including formulas. So I highly recommend this book if you're going to have a go at making gears. Now the Jerry Howell V-twin needs a variety of gears to be made. They're all 48 DP gears, and it needs, if you're going to make gears with gear cutters, you need 4 different gear cutters. You need number 8 to make gears between 12 and 13 teeth. You need a number 7 for 14 to 16 teeth. You need a number 5 for 21 to 25 teeth, and a number 4 to 26 to 34 teeth. And at the time I managed to get these 2 from RDG Tools in the UK, but they didn't have a number 8 and a number 4 in stock. Now I was very fortunate that Douglas in Pennsylvania, he managed to find a supplier in the States, and he managed to get hold of these 2, a number 8 and a number 4, and he sent them to me in the post. Ironically, I mean they're probably all made in China, but these 2 are definitely made in China. And they've probably been around the world once at least. But that's the way it is nowadays. And the other sort of like not issue but thing to bear in mind is that the cutters from RDG Tools have got a 1-inch bore, and these 2 here have got a 22mm bore. So nothing's ever simple nowadays. So for the secondary cam drive gear, of which I need 2, I've cut the blank, bearing in mind that this blank is sort of half the size of the drawing because the drawing's double size. And I'm going to stick it on this mandrel with a bit of super glue, and then for this particular gear I'm going to use the World of Ward rotary controller on the milling machine. So I've clamped the rotary table to the mill table. I've set the number of teeth on the World of Ward rotary controller to 21 and just press go. And that's taking up any backlash that there might be on the table. If I lock the table, now what I need to do is to just, well, I've got the right cutter in, and I need to just touch it on the blank. As it's just touching. Also bearing in mind that this cutter is exactly on centre. So now I need to move the table that way 45 thou. Lock the table, make the cut. Go back, unlock the table, go to the next one, lock the table and make the cut. And the final cut. So both of these teeth have been made on the World of Ward controller, and they look to have a really nice profile. And these are the gears without magnification. Happy with those. Well, there are quite a few gears needed for this Jerry Howell V-twin, all made out of leaded steel, and I've cut a couple of gear blanks here. There's 4 needed in total for the cam gear, and I think I'll cut those on my new Hobbing machine to see how they come out. This oil pump drive gear here, it's got a very small boss on the end, and that will need to be drilled at some point in time with a 32 thou drill bit, so that should be fun. But for this particular gear I've left it on the main piece of steel, so I can put that in the collet chuck, I think on the World of Ward rotary controller, and I'll cut these 32 teeth on that. And for the primary cam drive gear, there are 2 required. I've cut a couple of gear blanks, and I think I'll probably cut one on my World of Ward rotary controller and the other one on the Hobbing machine, just for a bit of variety. So this particular gear's got 32 teeth, so I've changed the gear cutter, so that's cutter number 4. I've changed the division controller, the World of Ward controller, to 32 teeth, and I just need to touch the edge first of all. Helps if I put power to the mill. Looking good. Well, that looks like a nice result. So all I need to do with this is put it back on the lathe and just part it off. I'll do that off camera. Well, I think it's my lucky day. I was just about to part this off and I realised that the boss on the end here wasn't long enough. 20th hour short. So I rectified that and then parted it off, so that looks pretty good. And that's another nice looking gear I've just made on the World of Ward controller. Just have a look at that under the microscope. Well, I must say I'm pretty happy with those. Look really good. Well, this is a very small gear. It's only got 13 teeth and we need 2 of them. It's for the pump gear and that's defined on page 19 of the drawings. And wow, these are tiny. It seems to engage very well. So these are the gears that I've made on the World of Ward rotary controller. And they are really small. And these go into there. Like that. They'll be Loctited in place, I think. So what I'm going to do now is go over to the Hobbing machine and I'm going to make the other gears that I need. I'll probably make some of these as well for comparison. So this is the little Hobbing machine, and I've used this 4-jaw chuck to centre the mandrel, and I've got a gear blank on there. So I've set the Hobbing controller to 21 teeth. Now the gear on the right is the hobbed gear and the gear on the left is the one that I made with a single cutter and the World of Ward rotary controller. And as you can see, the gear on the right has got a wider gap between the teeth. The teeth are generally thinner and there's a little bit of movement there. And on the right is a 32 tooth gear that I've just hobbed alongside another 32 tooth gear that was cut with one cutter. And as you can see there, just not quite right. Well, I've just got back from a long-awaited holiday in Malta, and while I was away, Douglas in Pennsylvania contacted me, and he came up with a great suggestion, and that is to use a calculator to check how accurate spur gears have been manufactured. And he provided me with a link to a calculator on the internet, and I'll provide that link in my video description. So I'm just going to have a look at, first of all, the gear that I cut with the single gear cutter, the 21 tooth one, and then I'll look at another gear, a 21 tooth gear that I cut with the Hobbing machine, to see what the differences are. So this is the calculator. Now ideally it would work better with an even number of teeth because you need to get the pins exactly opposite each other. But if it's an uneven number, you go for the closest one. So I've entered the number of teeth, the DP size 48, pressure angle. I don't know what manufacturing profile shift coefficient is, but a pin diameter of 1 millimetre, so 0.0394 of an inch. Then you hit calculate, and then it comes up with various information including the measurement over pins, which should be 0.4990 of an inch. Okay, so this gear was cut using a single gear cutter and the World of War rotary controller. So I've used some drill bits 1mm in diameter on opposite sides, and then I've measured the height of those, and that comes in at 0.501. So that is slightly oversized. It's 2 thou oversized, but pretty close. Now this is a 21 tooth gear that I've hobbed, and that's coming at, if we can get it, 0.485, 0.486 or thereabouts. So that's 13 thou out. So that actually proves that the gap between the teeth is slightly wider on the hobbed gear. And just out of curiosity, this is a 32 tooth gear that was hobbed, and this dimension should measure 0.731 of an inch, and it's coming at 0.714. So that's 17 thou under. So that again proves that the gap between the teeth is slightly bigger than what it should be. And this is a 32 tooth gear cut with a single gear cutter and the World of War rotary controller. And that's coming in at 0.726, should be 0.731, so that's 5 thou out, so that's pretty close. Okay, so that's all the gears cut, and these two here for the oil pump, and they were made by a single gear cutter. These two were made by a single gear cutter as well. That one made by a single gear cutter. These two made by a single gear cutter, but these four here were hobbed. So I think using that combination I should get a pretty decent result. Well, making all those gears was a bit of a marathon, and I never thought I'd end up making a hobbing machine. But it was an interesting process nevertheless, and hopefully now I can get this build of the Jerry Howell V-twin on track. So I hope you enjoyed the video, and I hope to see you later.